A problem faced by many designers is understanding how dimensional tolerances affect assembly performance. Gaining early insight into manufacturing requirements and assembly methods is valuable to keeping your project in budget and on time. Let's see how TolAnalyst solves these problems and gives feedback to improve the quality of your design. In this sheeter example, it is critical that the knife assembly maintains a specific gap between the blades for proper cutting performance. There are several components which contribute to this gap: the blades, the holders, and the bushings and pins. TolAnalyst leverages product manufacturing information, or PMI, created using the DIM Expert tool. To minimize the stack-up in our sheeter, we will control the location of the holes from the blade mounting surface, or datum A, and choose a press fit tolerance for the bushing bore. TolAnalyst walks through a 4-step procedure to create a study. First, we identify a critical measurement to analyze, in this case the gap between the upper and lower blades. Next, we identify the assembly sequence. The lower blade holder will be assembled first, the lower blade next, followed by the guide pins, the bushings, the upper blade holder, and finally the upper blade. The next step is to define how each part is constrained. TolAnalyst leverages assembly mates and PMI from DIM Expert for this. For the blade, there are 2 placement constraints available. We'll choose the one in the direction of interest, X. The guide pins get constrained to the holes in the lower blade block, and the inside diameter of the bushing to the guide pins. The upper knife block can be constrained to the guide pin OD, ID, or the pin OD. We'll choose to constrain the outer diameter of the bushings to the upper knife block to simulate the press fit. Finally, we'll constrain the blade to the upper knife block to complete the sequence. TolAnalyst immediately gives results. We are presented with the nominal measurement, the worst case minimum and maximum, as well as the RSS, or root sum squared, min and max. For this example, the blade gap must be between 0 and 0.25 millimeters to maintain proper cutting performance. Reviewing the contributor list shows each tolerance feature and its contribution percent on the worst case minimum or maximum. When you select an item in the list, the dimension or tolerance appears in the graphics area, or double-click an item to access the dimension tolerance or geometric tolerance dialog box, where you can modify the tolerance values in the part. Here we will change the position tolerance, locating the hole in the lower knife block, and click Recalculate to compute new results. We still don't meet our desired result for the gap. The upper knife block is now the highest contributing feature. Let's tighten up the position tolerance here and recalculate. We now meet our desired goal. But what if we consider the float in the guide pins? These close running fits add a bit to the calculated gap. However, we are still within our results, and we can see their contribution to the worst case minimum or maximum conditions. Finally, these results can be exported to an Excel spreadsheet to document the tolerance stack-up. This includes the analysis parameters, the measurement results, and the tolerance information for each of the features. Tolerance stack-up analysis is vital for validating mechanical fit and function and ensuring proper manufacturing and assembly processes are chosen. With TolAnalyst, these tasks can be completed directly on your models inside of SolidWorks, reducing errors and eliminating the need for time-consuming hand calculations or spreadsheets.